Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us start with question number 36. So far we have solved up to question number 35. So let us solve question number 36. Hello students, let us start with question number 36. The question is, consider a uniform spherical charge distribution of radius r1, that is uniform spherical charge distribution of radius r1. So this radius is r1, centered at origin O. So this is uniform charge distribution, obviously non-conducting. In this distribution, a spherical cavity of radius r2 centered at P. So there is a cavity made at the center at P, somewhere here. Suppose it is made somewhere here or anywhere, say here. P with a distance OP equals to A is equal to R1 minus R2. So this distance is R1, and the center is such that this cavity is made something like that, that this point is P and this point is O, OP distance. This OP is R1 minus R2. So this is R1, this should be R2. That means the radius of this one is R2. Smaller sphere radius is R2. If the electric field inside the cavity at position R, anywhere R can be anywhere inside the cavity, any position I will take. Might be I will take somewhere here. No problem with that. With R is the vector. E with respect to R, E as a function of R, then which of the following statement is or are correct? This means that if I have a situation like this, I have a radius over here and the point I consider is somewhere here. This is the point. This is my vector. This is my point, that is R. This is O, this is point P, this is point Q. This is Q. Then I can write that this vector OP and PQ, the vector OP vector plus vector PQ vector is OQ vector. So PQ vector is OQ vector minus OP vector. This OQ and this is OP. OP is R1 minus R2. Okay, OP is R1 minus R2, which is A. This is A. OP is A. OP vector is A. So OP vector is OQ vector minus PQ vector. OQ vector minus PQ vector. So I'll write OP vector is OP vector is OQ vector minus PQ vector. OQ vector minus PQ vector. OQ vector minus PQ vector. PQ vector is this one, R2, in terms of magnitude is R2. So we know that electric field as a function of R inside a uniform charge distribution of non-conducting spheres, this is sigma R upon 3 epsilon naught. So we have in this situation, this is sigma A upon 3 epsilon naught. Okay, we'll have this option 3. This is A of this. So E vector of R is, this is volume charge density A divided by 3 epsilon naught, and so epsilon naught R is any position. If electric field inside cavity at a position R is this, at any position, then the statement is R. At any position these are getting, that is A over 3 epsilon naught. So it is found that this is independent of, E is uniform, obviously uniform, and both in magnitude and direction, because this A is this one, this is your A, irrespective of whichever location you consider, whichever point you choose inside the cavity, the result is independent of that. The result only depends on this distance. Okay, the result depends on this distance, because this plus this is this one, so this is this minus this, that is, and so magnitude and direction uniform in magnitude and direction, and depends on A, obviously A, because depends upon A. So therefore this option is correct. Fourth option is correct. E is uniform, its magnitude is independent of R2, but its direction depends upon R, independent of R2, depends on this. So this is not correct. E is uniform, magnitude depends on R2, its direction depends on R. I think it is the same thing that is repeated. This is not right. E is uniform, its magnitude is independent of A. No, it depends on A. This is not right. E is uniform, both in magnitude and direction depends on A. That is correct. So this is the formula for electric field inside the uniformly charged non-conducting sphere. So the answer to the question is option number 4 is correct. Okay, thank you.